Yeah, so thank you for having me and welcome to my presentation. I'm Florian Berens. I'm new at the University of Tübingen. I was at the University of Göttingen before and just moved a couple of weeks. And the project I'm presenting today, I did together with my colleague from computer science, Sebastian Hobert. And you'll see in a minute why having a computer science guy was very helpful in this kind of project. I want to speak about statistics attitudes and also a bit about statistics anxiety. We all, or many of us maybe heard a couple of talks today on anxiety, and I'll have a part on that as well. But my main focus is on attitudes. And I will speak about the question why they matter. And to do so, I want to remind of us of all the research results that you can find in many kinds of publications, and maybe many of us who are teaching statistics also see that is reasonable, that there is a positive relationship between attitudes of students and their learning success. And also we had that in one of the last talks, there is a negative relationship of anxiety of students and their performance. So that is something that we often find in our courses and that we find in several publications, but we don't really deeply know why that is. So even if we see that that makes sense, we don't really answer the question why it is. And so there isn't much research, surprisingly, on why that would be. There is a paper by Levitas et al. They, based on self-reports, argue that it's all about the quantity of learning. So those who are motivated, have positive attitudes, are interested, then just do more, like answer more quizzes, are more engaged in their homework assignments and so on. And just like spending that more time makes them more successful in their classes. And there's a couple of others who also kind of hypothesize that way, but without really having empirical data about it. So that was kind of the basis that we started off from, and we wanted to know, is that really it? Is it really only quantity of learning, being more engaged, and to what extent is it? And so we first went into some theoretical explanations that we could think about to argue about these reasons why the positive attitudes make students successful in a way. One model that is quite famous is expectancy value theory by Eccles and Wigfield, especially. Expectancy, just to give it a quote describing what it is very briefly, Wigfield says, like, expectancy is all about, can I do this task? And value is about, do I want to do this task? Is it valuable to me to do that? And according to Eccles and Wigfield, these two, expectancy and value, both have an effect on students' learning success. A second theory that I apply, and that is kind of related but still different, is control value theory by Pekrun. According to that, the control students have about the situation and their learning, and also the value they attribute to the learning, they have an impact on learning success. And the one aspect that's very worthy in this situation is that Pekrun especially focuses on learning behavior as kind of the explanation why people are successful. Maybe that's just easy to do, to say like, okay, different learning outcomes is due to different learning behavior, but maybe that's not the only option. Maybe different other factors, as for example, intelligence, may also have an impact on learning outcome besides different learning behaviors. And another aspect that is part of control value theory that I want to use for my study is that Pekrun argues that control is influenced by people's emotions and, for example, by people's anxieties. So if people are anxious about statistics, they feel they don't have control, they can't do that task. And so therefore, I picked that aspect of emotions that is very strong in Pekrun's theory. So I picked these two theories, and I'll show in a minute how I combine that. And besides them, I also pick two other variables that are shown in many studies to be important. If we look at attitudes and anxiety, one is the gender of the students, and the other one is their prior knowledge in a way, or like their general. One could argue about having prior knowledge or competence or intelligence into it. The data that we had available was a high school GPA, so their grade point average from graduating from high school. So we could use that as some kind of proxy to look at what students bring to our classroom. Combining all these, this is the model I want to speak about and I want to think about. So I want to explain learning success. Students' attitudes as measured in expectancy and value are like the main first reason that is supposed to have an effect on learning success. And I argue that they both may have an impact on students' anxiety, and the expectancy value and anxiety all may influence the intended effort students want to put into their course. And that then has an impact on learning behavior and on learning success. Also, as I said, high school GPA and gender, in my case, I use female gender as the comparison. They have an impact on all aspects of that model. So what I want to answer in my empirical research is how these attitudes towards statistics impact learning behavior and success in a way that these positive attitudes are connected, and in a way that I can explain why they are connected to learning success. And my hypothesis would be that positive attitudes increase engagement, as we saw in prior research based on self-reports, and that higher engagement is a successful strategy in learning. But also I hypothesize that positive attitudes change how you distribute your learning. For example, you do more spaced learning, or maybe you learn at productive times during the day or the week, and that also is a successful strategy in learning. And as a third hypothesis, I think positive attitudes may also change your focus on learning. So for example, you may more focus on application, on trying to figure out like higher or in-depth learning, and not so much focus on just knowledge retrieval or so. So these are hypotheses I want to test. And to do so, I don't want to rely fully on self-reports. Of course, for some aspects of it, I have to. But I want to use digital behavioral data from my students. So together with my colleague from computer science, and that's a main point where he comes in, we created a learning app for the students in my class. And in this learning app, the key why we got funded and stuff was that we created a chatbot that was specific to statistics and to my statistics course. So in our app, students could just chat with our app to discuss statistics problems, to get help, to ask for terms, ask for formulas, and so on. So that was kind of the selling idea that we had, but also in this learning management system we used in class. We provided the lecture slides during the pandemic. We provided video recordings for the students to use. We provided quizzes for their self-study. They could participate in audience response actions during lectures and also tutorial sessions. They got access to their own learning statistics to have some sort of feedback. There was 2 quizzes a day, so to motivate them to have a daily learning routine. And also we did like a final lecture hall game to activate our students. And all these kinds of material we provided and all these kinds of options students had for their learning generated lots of behavioral data, because all the student interactions with this system were stored. And so we really have an in detail picture about what students do in our course. Of course, students can do learning without the app, can pick a book from the library, but as like everything that is related to the course is in that app, we are quite confident that we capture at least a lot of the learning that took place. And then we take that log data and we try to quantify it. We pick three main kind of like dimensions that we want to look at. One is the quantity, so the engagement of learning. There we look at videos, as data collection took place during the pandemic and students learned via videos. So we just counted how often a student would start a new video. And also we counted how often a student would start in a video that the student hadn't seen before. Of course, a student can watch a video several times. And in the first version, we would count that several times. And in the second, we don't. The same applies for the quiz questions that we provide for the students to do their self-study. We count the overall number of questions they take and also how many different questions they took. And we counted how often they were present in the tutorials that we had, that was video conferences during the pandemic. And so we counted how often they were present in the video conferences and how often they were active in audience response questions. Besides of having data on that engagement, we also have data about the distribution, and there we kind of had to design our own measures. So some measures were rather on something we would associate with spacing. So for example, we calculated, were they learning during the course, so in parallel to the course going on, or were they just learning for the exam shortly before the exam? So we calculated the proportion of learning that took place during the course as opposed to shortly before the exam. And also we did the same for videos. So were they watching the videos during the course as opposed to shortly before the exam? And so not only having this like full span of a term, we also looked at, do they learn 9 to 5 within the day, or do they learn like at night or so? And we looked at, do they have that one day in a week where they mainly learn, like maybe a student chooses to learn on Wednesdays for the statistics course and on Thursdays for another course, or maybe students just do it whenever it fits and so don't have that like regular structure in their weeks. So that was things we calculated based on the question data and also based on the video data. And for the video data, on top of that, we also could calculate the time leak. So the difference between a video gets uploaded and the student watches the video for the first time. And so we calculate how many time passes in that to have a measure of academic delay, or you may name it, may call it procrastination in a sense, that we wanted to capture with that. And as a third dimension, we also wanted to look at the focus of learning. And there we classified our questions. We had, are they more like application oriented, or are they more knowledge and understanding focused, and also calculated a proportion in that. So that's how we looked at learning behavior. To have the attitudes, we used the SATS survey. That is probably the most prominent attitude survey in statistics education research. There's 6 dimensions in the original publication, or not in the original, but in the 2003 publication that many use. And this survey is also based in expectancy value theory that we use in our research. So I think that fits quite well. And if you ground that survey in expectancy value, then the cognitive competence and the difficulty dimension of the survey, you can group to expectancy, and the affect, the value, and the interest you can group into value within the expectancy value theory. And the effort component is kind of different. For example, with Ramirez et al., you could argue that that is a special kind of construct that we put in another place in our models. So to have a full overview about the instruments we use the SATS 36 for expectancy, value, and effort. We use the STARS questionnaire for the anxiety. I saw the STARS questionnaire popping up today a couple of times. We used the learning behavioral data as I showed. Gender was something we could get from the exam registry. Also from there, we could get whether the student had taken the very same exam a year before and failed, that would be why the student would take it again. And we excluded those to really be sure that it's only first-time participants, because we think that participants that are there for a second time have different learning behavior and also different thoughts and attitudes about statistics. So that we excluded them. We have the high school GPA as part of the survey, where we also did the SAS, and we can match the exam data. We had a written exam of 90 minutes with 25% conceptual questions, 40% calculations, and 35% interpretation of statistical results. And that is then the final measurement of student success in that course. Our study took place in the University of Göttingen in Germany in the summer of 2020. The students that are in that course are social science students. Usually they had one course on research methods before, but not a statistics course, but rather general, what is an observational study opposed to an experiment kind of introduction. In this course, in this statistics course, that is usually in their second semester of studies at university, we have 722 students registered in the beginning of the course. 286 of those took the final exam. 271 of those participated in our survey, and then excluding those who took the exam for a second or third time, we land at 238 students being the sample we use for our study. Looking at these numbers, I have to say, I guess that's not unusual, and that's also not specific to the pandemic that we lose that many. So having that high of a dropout of about almost 500 isn't. So I guess it's special in a sense, but it's not that it's special in that year or so, but it's happening every year just because of how the university regulations are. So jumping into first results, I, as an example, pick a structural equation model where I have the total number of watched videos as the variable describing learning behavior. So that's the very same model I had on one of my first slides describing my theory. And just now I inserted the total number of videos watched as the learning behavior variable. And if you look at that, you see that we see effects on learning success. So for example, how many videos a student watches has an effect on their learning success. But the even bigger effect is by high school GPA. And apart from that, we see that expectancy and value have indeed an effect on the intended effort, and intended effort has indeed an effect on the number of videos students watch. We see that expectancy also has an effect on anxiety, but having like this kind of full model anxiety doesn't have any further effects. Of course, due to the correlation between expectancy and anxiety, there is correlation between, for example, videos total and the anxiety of the students. But if you specify the model that way, you wouldn't find an additional effect of anxiety on the number of videos that students watch. So that's just one example. In the first step of calculating my models, I just did this very same model just with every behavioral variable I have, so 13 models. And then I went through and compared the models. And so having the three main groups in mind, like some variables measuring more engagement, some more spacing, and some more like the focus of learning, I took those variables from every group that were the strongest in predicting learning success. And doing so, I arrive at that model. So the total number of questions a student answers with counting only distinct questions is the most strong in predicting learning success overall. So the more different questions the students answer, the more successful they are. But also the amount of videos they watch during term opposed to shortly before the exam has a significant effect on their success. And also the rate of application questions they do has a significant effect on their success. And those two last ones are about the same size as high school GPA, as you can see, while the engagement effect is way bigger than that. And you see that the intended effort students have has a significant effect on the number of questions they do, and that's the same for like all the engagement variables I used. And also effort has a significant effect on spacing, in this example, the videos they watch during term. And as we saw in the first model, expectancy and value have an effect on the intended effort, while anxiety doesn't have an extra effect besides the correlation to expectancy. And we also see that not only high school GPA, but also female gender is very important in all these considerations. We see that there's no like direct effect left on learning success in this model, but there is a gender effect on how they focus in their learning and also on intended effort, anxiety, expectancy, and value. So my conclusions on that are that expectancy and value indeed have an effect on scaling and on spacing in learning, and that anxiety doesn't have like an extra effect on that. High school GPA is particularly important and is partly responsible for the relationship. So we see that expectancy and value have an impact on learning behavior, but also this effect between expectancy, value, and success is partly due to correlations to high school GPA. We see that the learning behavior variables indeed have effect on learning success. And I interpret that as some support for expectancy value theory and control value theory, even though not as full support, especially regarding anxiety. To say something about limitations, this study, as I said, is based on one single course in one single university. And especially what is important about that course, that it is a mandatory course. Students aren't free to choose that course, but it's just part of their study program. So that would be interesting how all these things would work in a course that students are just free to choose. And of course, it's another interesting topic to see who is dropping out and why students are dropping out, to which point in time during the course. So that are parts that I want to do in future research. And also these, what I introduced, are some ways of speaking about learning behavior and measuring learning behavior based on digital behavioral data. But of course, there may be way more ideas and good ideas that I'm happy to learn and happy to test. And so that's something I want to do in future research. So thank you for listening, and I'm happy to take all your questions.